Hello friends, I am back with the new path in our NLP course, which is based on the tutorials provided by the Hugging Face. Let's get started. So today we are on to the sub-chapter called models. In this chapter, we will have a closer look at how we create and use the model, and we will use auto model class, which is a handy way to instantiate any model from a given checkpoint or the checkpoint that we describe. So yeah, going instead of going through all this theoretical part, I will be directly opening the file in the Colab and will be discussing the things that are going on here with the coding. So let's open the file in the Colab. Yeah, this let me summarize it in short. So this topic will deal with creating the model from the scratch, how to describe the config file, and how to instantiate the model with the default parameter or the parameter that we import from the checkpoint. In the both way, we will try to instantiate our model, and also we will learn to save the model, how we can save the model and what are the files that are saved. And then we will also try to change the number of sequences into the IDs, as we have already discussed. To manipulate the words or the sentences, we need to change them into IDs, and which can be processed by our model. And in the same way, we will try to change those ID into the tensor form so that that can be given input to our model class, which we have instantiated, and they will provide us the appropriate output. So let's get started. So yeah, the first step is always installing the requirements. So let's install the requirements. I want to run it anyway. And after installing them, what we need to do, we need to import the bot config and bot model from the transformer library, as we are planning to import the configuration from bot config, and we also try to instantiate object of the bot model class. So here we will config, or we generate an object of the bot config class or instantiate it, and it will contain the default configuration for the bot model, and with the help of that default configuration we will instantiate our model object. So let's do it. So these are just the lines. To first line is to generate the config file or building the config, and second one is to instantiate the model object from the generated config file. Next, let's try to have a look at the configuration. What are the various things? As you can see, the various things are listed here. We can go through them one by one. I will try to explain few of them. If you need for any further kind of exploration, you can easily find them. So let's go through few of the parameters. So the first one is attention probability dropout probability. So attention, there are many attention head, as we have mentioned, and so this is the parameter that is specifying the probability, dropping probability of those attention. And second one is the classifier dropout, which is set to null. It means default value of the classifier dropout will be used. Hidden layer activation function is set to JLU, and hidden dropout probability 0.1, hidden size 768, and so on. So these are the various kind of parameters that are used for instantiating the configuration file, which is used for instantiating again the model class, model object. And the next step will be to instantiate it. Yes, so we will establish config and then use that config to instantiate our model. And the thing is that in this case our model will be initialized with the random value, as we are not providing any kind of checkpoint from where the weight of the model can be established. So model is randomly initialized with some random values. Now if you want to use some checkpoint to initialize our model, what we can do is we can again use but model dot now from pre-trained, as we have already used this function in our previous lecture as well. Here also we need to import from pre-trained and pass one checkpoint that we are using to initialize our model. So here in this case we have used bot base case to add the checkpoint which will initialize our model. Now the second point is after we have initialized it, and next phase is to know how to save our model. For saving our model, it's straightforward. We will use model.save pretrained, as there is from pretrained we have save pretrained. So we just need to pass the directory or the path from where we want to save our model, and it will directly save the model. So it's a straightforward one. So when we run it, our pre-trained model will be saved. When we have a look at it in the directory, we'll find one config file. Let's click it, and here there are the number of parameters which have the value, and they are mentioned over here. And in the same way, there is another file called pytorch model.bin. It won't get open. It is the heavy file, and it contains the binary numbers. We can see it. It's 413.23 megabyte, and it contains all the weights that are used for initializing our model. Yeah, so when we try to save our pre-trained model, two files are required. One is configuration file that will focus on the layout of our model, values of the various parameters, and then next file that is saved is the binary file containing the weight of all the nodes. After that, let's move on to the next part, which talk about encoding the sequence. So let's define some sequences. So here are the sequences: hello, cool, nice. We have 3 sequences, and then when we try to encode those sequences, we try to encode those sequences using various IDs. We will talk about encoding in detail in the coming section. Let's suppose we have encoded those sequence. Now after encoding, we need to convert those encoded sequence into the tensor, so that they can be given as the input to the model, as model only worked on the PyTorch tensor, as we are using the PyTorch as our working tool. And then we convert them into the tensor. Now those tensor can be passed as the input to our model to get the proper output. So yeah, so this chapter mainly provide you the brief idea of how we can load the model, how we can configure the model to some random values, or we can also configure the model to load from a certain checkpoint, so that we don't have to pre-train our model, and we can also save some energy, or we can neglect the carbon footprint that is released while training our different model. So yeah, so this is all about the models. Let's move on to the next part, which talk in detail about the tokenizers. So as we have already discussed, the tokenizer is the thing which help us to divide the long sentence or a raw text that we give as an input to our model into the smaller tokens. So tokenizing can be done in various ways. Let's have a look at them. So yeah, the first simple straightforward option is to split on the basis of spaces. So we have, let's do tokenization. We can split all of them on the basis of space. So we have 3 tokens. Let's do tokenization. And further, if you want to split it on the basis of punctuation, we can again split it. So we have let, apostrophe s, do, tokenization, and exclamation. So we have different options. But the thing important here is that we need to use the tokenizer, which will be able to generate the tokens containing less number of unknown tokens. That is the token that are easily understandable by our model. So main focus should be that. And while doing so, while creating the tokens from the words, it will be very hard to cover all the words, as many languages can have a large number of words and covering all those words might be difficult. For example, there are over 500,000 words in English language, so there can be even more. And also the problem with those word tokenizer is that the words like dog, dogs are similar, but they will be treated as different. And in the same way, the word like run, running, runs, rain are also similar, but they will be treated differently. So yeah, so we can also have some unknown words which are called as unknown token. We need to minimize those tokens, as well as we need to see if we can try to regroup all the words which have similar meaning as near as possible. So one way to reduce is the unknown tokens is to use the character based tokenizer. That is, we divide whole sentence character wise, but the problem is that with those they won't be able to group the related tokens, so it will be very hard to put the related tokens together. So we focus as a result of those problems, the thing that is regularly done in the NLP field is the software tokenization. It takes the advantage of both the techniques. So it will reduce the unknown token as well as try to put the things which is used more frequently under one domain. So this is the approach of software tokenization. Let's, for example, again look at the same sentence. Let's do tokenization. What it will do is it will put let's into one category. It is the most commonly used word. Do as another token. It is again the most commonly used word. Token, it will break the tokenization into two parts, token and ization, as token is the most commonly used word, and further ization can be collaborated with the other word to form anything like ionization, factorization, and so on. So it will try to create the token which is mainly focused on reducing the unknown tokens as well as grouping the related tokens together. And surprisingly, there are many other tokenization process as well, like byte level tokenization, word piece tokenization, and so on. As we are evolving in the language model, they are customizing the tokenization algorithm depending upon their model. So they are also customizing it so that this tokenization process suits the model at which the company choose for their language model. So it totally depends on that. After that, we will move on to the loading and saving those tokenizers. I will explain this part through the collab file, and then we will also try to see how the encoding works in tokenization. As in tokenization, we just create the word, and our language model want to work on the tokens. They need to be converted into the IDs. So that is taught by the encoding process. Let's go through them in detail. So let's open the collab file. Let's move on to the collab file. Let's leave it. Now, as we all know that we have to install the dependencies, so let's install the things, and then we will start by importing by simply using the default tokenizer, which will generate the tokenization on the basis of the steps on the basis of the space. Sorry. So let's try it on this one. So what it will do is we will have a sentence: Jim Henson was a puppeteer, and we will try to split it and print the tokenized text. Let's do it. So what it will do it is tokenizing the sentence based on the default white spaces. And let's try to import bot tokenizer, which is the tokenizer used to pre-train this bot based model. Let's import it. It's being downloaded. So from the, yeah, I don't know why they have put the same thing twice. Those are the same thing which we have already done. When we try to run it, I think we have already downloaded the model, so it will work on the cache, and then we are done. Okay, now let's use this tokenizer to tokenize this thing. When we use the tokenizer, as we all know that we will get our dictionary containing the input IDs of the words, and then again we have the token type IDs, and then we have the attention mask. This tokenizer is the default tokenizer that we have imported, and which is used during the pre-training process of this bot-based case model. Now what we can do is we can save this tokenizer as well as we have done with our pre-trained model. So let's try to save it on our system, and let's have a look at the file that it has generated. So first of all, spatial tokens map.json file is generated. Let's have a look at it. So it will explain the spatial tokens that are used. For example, this CLS underscore token is represented by this symbol, and it is used as the classification token. This mask token is for the masking purpose, and for the padding this token is used, and for separating purpose next token SCP is used, and if we have anything unknown tokens or unknown word, which it is represented by this token. So yeah, this file is for representing the spatial token which have the special meaning. And then we have next file which is called tokenizer.json. So it will represent all the things like configuration of the tokenizers, type and versions of the tokenizer, as you can see, and then we have special token mention, rules and regulation of the tokenizer, and so on. So this is somewhat like the things which describe the algorithms and other items used during the tokenization process. And next file that we have is config.json. It will have the values for the different parameters, like what is the tokenizer class, what is unknown token, what is classification token, and so on. It provides the configuration for our tokenizer. And then we have vocab text. So it contains all the words that are used in our token, and it lists in our case how many words are there. There are 28,997 words which are used as tokenized, which are used. So it contains all the words that our model know. If we get the words which are not present here, then we have to put our unknown tokens data. Okay, so let's move back to our code. Okay, so in this way we can save our tokenizer model, and then what we can do here, we can use this tokenizer to tokenize the sequence. Let's see how it works. So what we have done, we have imported auto tokenizer, and then we have used the auto tokenizer which is used for tokenizing this pre-trained model bot based case, and then we have given the sequence using a transformer network is simple as an input to the tokenizer, and try to print what are the tokens that are available in our sequence. Let's run it, and we will get the tokens. So what it has done is it has simply put all the words together. For transformer, it has divided trans and former. Now we can print the IDs of the token with the help of this function tokenizer.convert tokens to IDs, and then we can pass the tokens that were generated, and we will get the IDs of corresponding tokens. Now what we can do, we can use again the decode function and pass all the IDs to it, and we will get not only the tokens back, as well as the tokens are rearranged to the sentence, which are easily understandable by us, like this one. So yeah, we can again try to experiment on the things. Yeah, it will take some time to rearrange the thing. We can write something, I love playing football, and then try to repeat all the stops. So it's a I love playing, so it didn't divide play into play plus ing. So it depends upon the tokenizer you used. So it's not universal that it will be divided into the things that is used by us. All it depends. Okay, so what happened here? I love playing tokens. So ID tokens. We have 4, 1, 2, 3, 4, and then oh, I didn't pass the ID, sorry. So that's the reason it's giving me the wrong answer. So let's pass those IDs. Now if you try to run it, it will recreate I love playing football. Yeah, so this is all about the tokenization thing. Now yeah, we can also further move on to how we can handle the multiple sequences. So here the thing is that in this sometimes we will have to handle multiple sequences. So in the previous example, just one sequence is provided, so it was easy to handle. So this topic or this chapter will talk about handling the multiple sequences, how we can handle them if they have different length, and what are the problems that we encounter during the handling of multiple sequences. So this chapter talk all about it. So they are explaining the things through the code part. So without getting any delay, let's open the Colab file and discuss about the thing, how we can handle the multiple sequence that are mentioned. So yeah, let's first import the file, which is straightforward thing. After importing the thing, we will import our required library, like we need auto tokenizer, and then we need auto model for sequence classification, and then we will need one checkpoint from where we are going to load the weight or instantiate our model. So our checkpoint is here, which is one of the models good for sequence classification, and then we will pass that checkpoint to our tokenizer, so that we will import the tokenizer which has been used to pre-train this model, and then we will use this model so that it will be instantiated from the weight provided by this checkpoint, and we will define some sequence which we will give as an input to our model. So before that, we need to tokenize things. We will tokenize it with the help of tokenizer that we have imported, and then we will generate the IDs, and we will pass the ID, and then we will, after generating the IDs, we will give that ID to our model. And as you can clearly see that this line will fail. We will talk about why this thing fails at first, and then we will move on to discussing the thing. But as in our previous case, we are doing all the things that we have done in the previous example. This is failing. The main cause of its failure is that we haven't converted those IDs which are written from the tokenizer into the tensor. As we all know that our model works on the tensors, and we are directly passing the IDs to our model without converting them into the tensor. So that is the main reason our model is failing. Let's add one more dimension and create the tensor so that we can easily pass them into our model. So let's move on. So at first we will tokenize our inputs. Yes, so our sequence is the same sequence. I have been waiting for Hugging Course for my whole life, so same sequence will be used. And what we need PyTorch tensor, and after this we can pass those tokenized inputs and the form of the, as we get PyTorch tensor, and we can pass those and get the input IDs in appropriate form. Here the input IDs are not in appropriate form. As we can see it, they are directly tensors generated, but we need the PyTorch tensor to work with our model. So that is the problem with the first one. Now let's add just one line and let's redo the things. So this is almost the same code from the above part. As you can see, nothing more is here. What we have done is we have just added one line. So what is that line? ID tokenizer convert tokens, and we have this one, input IDs. So here we are lacking that line, and we have supplemented that line over here, and as a result of which our model will start to work. So the main problem was that over here too many indices for tensor of dimension 1, so we need to add one more dimension, and we have added that with the help of our tokenizer function. While passing sequence, we order it to return the PyTorch tensor, which was missing in the above case. Now after getting the logics, what we can do is we can try the different items. For example, we have a sentence, we have more sentence, I mean 2 or 3 sentence, but we have different length, like they have different batch IDs 200 200 200, but the problem is that second sentence has just 2 tokens. What we can do is we can use the padding concept, as we have already discussed about this parameter. So padding is the parameter that is used to maintain the length of the sequence so that they have both the same length, and we can have a rectangular matrix so that it can be easily manipulated by our model. So we will have a padding of 100 over here, and then now what we can do is we can use these to generate the output. So let's see how it goes. Let's run it. So what we have done is, so sequence 1 ID is 200 200 200, sequence 2 ID is 200 200. Now the batch ID is 200 200 200, and for this one we have given a padding token ID, so that the padding token will be inserted here, and they will have a rectangular matrix so that our model can work on it. So when we try to print the logics, what we can see is for the first sequence we get 1.5694, and for the second we have minus 1.349. So while giving first sequence ID as an input, we get this output, and in the same way for the second one we get 0.580 and minus 0.4125 as the input. While passing them together as a batch, we can see that for the first one we get the same values, but for the second one, to our surprise, we are getting the different values, like 0.5803 over here, and at the bottom we can see 1.3374. So it's quite strange. The reason is straightforward. As we have seen in the previous video, there is one attention mask. We haven't used that part. as the main role of the attention mask is to provide the significance, whether we need to consider particular token under the processing scenario or not. As we may have some padding tokens which are not the useful tokens for manipulating the output, so we need to ignore that, and that thing can be specified by the attention mask. So we need to take care or take attention marks under the consideration so that we can have the result as the individual case as well as in the batch case. So let's make the use of the attention mask. So over here we repeat the same batch ID, and now we provide the attention mask. So as this last token is the attention mask, we give its value 0 in our attention mask matrix so that it won't be taken under consideration during the processing scenario, and it will get slightly modified. What we need to do is we need to pass the same thing, and further one more argument come into the action, which is attention mask is equal to torch.tensor attention mask. So we will use this one. Now if you run that, we can clearly see that we get the same matrix when we run that sequence independently as well as under the batch. And one more thing is that if we sometimes we can have a long sequence which are not which cannot be handled by the model, as all the model have their one handling capacity of the sequence, so they have fixed length of the sequence that they can handle. In that case, what we need to do is we need to truncate that sequence with the value max sequence length which is specified in the model, and after that we can pass our sequence for the tokenization as well as the encoding process. So this is the things mentioned in this part, and in the next topic I will be talking about the last topic of this chapter. We have discussed about the models, pipeline and tokenizers and sequences in detail. Now in the next video I will try to put all the things together, and we will make one model work. Thank you so much. See you soon. Bye bye.